A cryogenic vial can remain physically intact and still become operationally useless if its identity cannot be confirmed at retrieval. The reverse is equally serious. A readable code does not compensate for an unsuitable closure. Sealing, coding, and retrieval must therefore be qualified as one connected control system. The assessment should follow the vial from receipt and aliquoting through identification, racking, vapor phase storage, retrieval, scanning, and return or consumption. At each stage, the failure consequences differ. Leakage can threaten containment, sample condition, nearby inventory, and confidence in the storage event. Coding errors can compromise identity and chain of custody. Rack incompatibility or poor scan geometry can delay recovery or produce location errors. A practical risk matrix considers 3 factors: severity, exposure, and recoverability. Severity reflects the potential effect on containment, sample condition, identity, or release. Exposure considers how often the workflow creates an opportunity for failure. Recoverability asks whether the correct physical condition or digital identity can be restored with confidence. Failures that could compromise containment or create an unrecoverable identity error require the strongest evidence and should block routine approval until effective controls are established. Closure qualification begins with the exact combination of tube, cap, thread geometry, rack, and handling method. Internal thread and external thread designs may support different workflows, but neither format is universally preferable. Operators must be able to close the vial consistently while wearing protective equipment. The vial must seat correctly in its rack, and the cap must remain manageable after cold exposure. Any torque expectation and automated decapping requirement should also be defined. Temperature transitions deserve particular attention. Movement between storage, workstations, scanners, transport containers, and analytical equipment can affect frost, grip, code visibility, and cap operation. Testing should represent the longest likely handling sequence and identify when the code is scanned and when the closure is challenged. Leak resistance claims are useful only when their boundaries are clear. The evidence file should identify the test method, pressure or vacuum condition, duration, sample configuration, temperature context, acceptance criterion, and document revision. Transport evidence may support shipment-related containment, but it does not automatically establish performance during vapor phase storage and repeated retrieval. Local verification should address any conditions left unanswered. Coding validation must extend beyond optical readability. Each physical mark must connect to the correct digital record when an operational decision is made. The documented configuration should include the code format, uniqueness logic, marking method, reader, rack position, and software response. Scanning at accession, storage, retrieval, and return should produce the expected identity and event history. Deliberate exceptions are essential. A vial placed in the wrong rack position, an unassigned code, a duplicate, or a value outside the approved sequence should trigger a controlled response. Exception records should preserve the original scan, investigated cause, corrective action, and final reconciliation. Manual fallback procedures must not create a parallel identity that later conflicts with the scanned record. Representative retrieval testing should include gloved handling, frost exposure, rack orientation, accessible scan angles, repeat retrieval, and the intended time outside storage. Reader settings, rescan rules, difficult code locations, and observed failures should be recorded. Automated workflows require testing with the intended rack and equipment combination. Qualification then becomes a controlled sequence. Define the use case. Record the selected configuration. Review applicable closure, temperature, cleanliness, barcode, and quality evidence. Test sealing under representative handling conditions. Verify the complete scan-to-record chain. Document acceptance criteria and deviations, and establish revalidation triggers. Changes to the closure, code format, rack, scanner, software mapping, manufacturing source, packaging, or supporting evidence can all justify renewed assessment. The result is a defensible connection between product configuration and workflow performance, preserving confidence in both the physical sample and its digital identity.